Hi everyone, and welcome to our video on graphing some sine functions. So we're going to graph two, but we're going to introduce the generic forms for these more advanced trig functions. So in the previous video, we graphed just sine of x and y equals cosine of x. So they always look something like these two, but they can start throwing in values and it's going to change it a little bit. So the shape's not going to change, but we'll deal with our x coordinates and y coordinates. All right, so these are, I got my pen. When I say form, let's add non-shifted form, where we say this a value, if we take the absolute value of it, is the amplitude. Okay, so the sign is still important though. So sine of just a is important because that sign, if it's negative, will tell us to do our reflection. And then this b value helps us find the period. So the period is based off of 2 pi divided by b. So whatever that b value is. All right, and sometimes they might use different letters. So they might use like lowercase a, they might use kx instead. So they can change those letters, but it doesn't change the way that we break it down. Also, this really should have parentheses on it, but they don't often do that. Okay, so they often just leave it as it was. Okay, but I'm going to add it to this problem there. So the b, notice the b, oops, I wrote period is equal to b, but let me erase that arrow. Okay, so I'm just going to have it marked. So the b is not the period. The period is 2 pi divided by whatever b is. All right, then our sine curve, again, always starts at 0, 0, and then always looks something like that, where we can figure out these a values, and then we can use our period to help with the rest. So remember, the period is this full length right there. Okay, and we'll get to showing how we deal with it in a problem with actual numbers in a second. Okay, the cosine is the same deal. The a is the same, and the b still helps us find the period. So I'm just putting little arrows, but the main difference is, well, cosine looks something like that. And in both of these, we want where their peaks are and where they cross the x-axis. So those little tick marks that I'm putting, along with the 0, the origin, are values that we're going to want. Okay, so let's see two sine functions. Let's do two sine functions in this problem. I have cosines after. So determine the amplitude and period of each function and then sketch its graph. All right, so we'll break it down. We say, all right, here is our a. So our a is 4, and that means our amplitude is 4. Okay, so it's positive a already. So I usually don't mark it. If it's negative, I'm going to be more careful. All right, and then this is our b value, which means our period is 2 pi divided by whatever that b is. And I put the letter b right now in this problem, but you can instantly say, well, it would be 2 pi divided by whatever b is, so you can put 2 in. And then do your simplifying like normal fractions, our period would be pi. So the 2's cancel. And then now we're going to make our generic sketch of our sine function. So I'm going to do the generic sketch first. Some students like to do the points first and then draw the sketch. But after this, all we do is we label the amplitude. So that's our y values of importance. So there's 4 and negative 4. And then now we use our period. So the period is this whole length. Well, if I start at x equals 0, that means the length here is pi. And then afterwards, I do a technique called half times 3. Oops, let me write this vertically. Half times 3. Okay, the reason I call it that is, well, this is a halfway point that I just marked between 0 and pi. And then this is a halfway point of the one we will just have found. And then if we count the tick marks, 1, 2, 3 would give us the next important point. The other way to think of halving is to multiply denominator by 2, and timesing by 3 is to multiply a numerator by 3. Okay, so let's see this. So step 1, so we're going to half. So we're halving this pi. So again, we want the 4 that I'm about to highlight. Well, it does have a 1 under it if I do want to put it there. So I'm going to half it. So that means multiply the denominator by 2. And that would be that x coordinate. Okay, and then now that I've got this, okay, so that was step 1. I halved that, so it's going to get a little messy on this problem. So that was step 1. Step 2 is to half this again. So half. So this is our second half. So which is to multiply the denominator by 2, which would be pi over 4. Okay, so multiplying the denominator, 2 times 2 is 4. And then that's our next important point. And then the last step is to times what we just found by 3. Okay, so this, I'm going to dot it because it's messy. But times that one by 3, which is timesing the numerator by 3. Well, pi times 3 would be 3 pi, and then 4 down below. Okay, so there they all are. So those are important, and I'm just highlighting them, values. And then just to highlight the graph, because the dotteds might be a little distracting. Okay, so that is the sine graph. Okay, so this one got messy because of the half times 3 that was shown in the problem. Okay, and that dotted line was the third step, so half times 3. Okay, and that gives us our sketch very quickly. All right, so let's try it with this other sine curve. So here we have the a is equal to -1. Now that's where I would put a big old star by it. The negative is telling us we will need to reflect. Okay, but continue onward and get the amplitude. So the amplitude is +1, and they want that. And then our b value, okay, so looking at our b value, remember there's a 1 there with that x. So it's whatever's attached to the x is the b value. So the b value is 1/7. And then the period is to take always 2 pi in the numerator divided by that b value. Okay, so your b can be a fraction. And then when it's subbed into the equation there, we need to clean it up because it's a fraction and a fraction. Well, all I do is take whatever this denominator is and multiply both the top and bottom by that number, because that will cancel that 7 and that 7 out, and then I'd be left with just 1 in the denominator. And then up top, 2 times 7 is 14, and then pi is attached. Okay, and then just as a placeholder, yeah, that 1 is still there in case it's any other number. But I'm going to go over here to the side. We usually don't need to show 1. So let's just say the period is 14 pi. Okay, so that's our information. Our amplitude and our period, however, again, it's reflected. Now, like before, I'm going to just draw a generic sine curve. I'm going to do this one dotted, though. So here's our generic sine curve. Dotted. But we need to do the reflection. Okay, so the reflection means we mirror this image across the x-axis. Okay, so the x-intercepts will be the same, but this peak is now going to be down first, and then the bottom peak on the right is going to be up. There we go, that's it. So that's the reflection, and then still we label the peak up top 1 and -1 because of the amplitude. And then now we'll use our period. It's 14 pi over here. And then now we'll half it. Okay, so, and again, you could put a denominator of 1. However, I think halving is actually better in this case because 14 halved is 7. and then just attach the pi, 7 pi. Now it might be better to say, well, there's a 1 down there, and if you multiply the denominator by 2, that's where that bottom peak is going to have that x coordinate, so 7 pi over 2. And then now times this by 3. 7 times 3 is 21. Attach the pi, divided by 2. There we go. And then let's label the origin 0. And we've got it boxed up. That's our final sketch. Okay, and I think it's good just to label the x and the y axis like that. However, if you want to, you could label the actual points. So here's 7 pi over 2 and negative 1. And then here's 7 pi and 0 and so forth. One reason it might be nice to label the points is we can check our answer by using, again, the unit circle, at least one point. Okay, because that point has the x coordinate of 7 pi halves. Okay, so I'm going to label real small there, and a y coordinate of negative 1. So that means if I go back to my original function, y equals negative sine of x over 7, and I plug in that x value, so y equals negative sine of 7 pi halves over 7. What's going to happen here is these 7's cancel. So we would have negative sine of pi over 2. And then I'm going to put that in a bracket. Sine of pi over 2 is 1. And then this negative is still just there. And that matches that y coordinate. Check. Good. Okay, and we could check in with all of those points if we need to. All right, but that's it. I think it is correct. If you do want to double check, yeah, it's going to work. Okay, so, and this is our quick sketch of our sine function here. Okay, so there's 2 problems with sine. I'm going to take a break. Let's do cosine in the next video. So thank you for watching, and I'll see you next time.